Good morning, Algebra 2. Since we're starting new content with our Titan Learning Day 24 and 25, I'm going to give you some notes to help you out. If you have questions about anything, you can send me messages on Remind. I think all of Algebra 2 is on Remind, so we should be good. We did 13.1 in class, and for homework, I think we did Form G. So Titan Learning Day 21, I think, was Form K. Then we did 13.2 in class, and then 22 and 23 were Form G and K, and now we're at 13.3, which is Radian Measures. So let's remember a little bit about geometry. What is a central angle? So central angle of a circle is an angle with a vertex at the center of the circle. So this is going to be a central angle. It's like a piece of pizza. So when I taught it in geometry, I would say this is like a slice of pizza, and then this arc is like the pizza crust. Or this is like a slice of pie, and this is the back of the crust. So that's going to be your central angle. An intercepted arc is the portion of the circle with endpoints on the sides of the central angle and remaining points within the interior of the angle. So if this is the central angle here, then this is going to be the intercepted arc, and here would be an endpoint, and here would be an endpoint. Now let's remember that the measure of a central angle is always going to be the same as its intercepted arc, which makes calculations with that very easy as long as you remember that. So moving on to new stuff, we're going to talk about a radian. Now, as we go through, when answers are in radians, you're going to have to shift your calculator over from degrees to radians. Usually we do everything in degrees, but if you go into the mode setting, you can switch it to radians. A radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. Okay? Radians, like degrees, measure the amount of rotation from the initial side to the terminal side of an angle. So a radian is just going to be the way you measure it. Degrees is another way to measure it. So radians, like degrees, measure the amount of rotation from the initial side to the terminal side, repeating what I just said. All right, to convert between radians and degrees, this is basically your proportion, okay? So this is how it always sets up. Degrees over 180 is equal to the radians over pi. All right, now, I think I made a note in here somewhere about the unit circle, but now I can't find it. Anyway, let's do a brief look at the unit circle, and you can freeze the unit circle and look at the unit circle whenever you want to. So let me slide this over, and hopefully you guys will be able to see the unit circle that is drawn in the back of my textbook for us. All right. Can we all see that? Hopefully. I'm getting the bottom. I'm not sure. Let's raise it up just a little bit. Yep, I think we're getting it all. There we go. All right, so this is your unit circle. You're going to have to memorize it next year, so you can take a picture of this, you can screenshot this, however you want to do it, and I would start utilizing the unit circle for some of my work. These are notes, quadrant 1, of course, quadrant 2, quadrant 3, quadrant 4. That always makes the C in the order that you number your quadrants. Little helpful hints, one less than the denominator. So on these, that's a hint that'll help you memorize how these go. 3 is 1 less than 4, 5 is 1 less than 6, and so on. Down here, it's going to be 1 more than the denominator, 5 is more than 4, etc. And over here, all of them are prime numbers. So 5 is prime, 7 is prime, 11 is prime. Whatever tricks help you memorize it. This is something that you're going to have to know for pre-cal trig or math 111, 112. So this is the unit circle. Now, we're going to do things without having the unit circle memorized, but it would help you to go ahead and memorize it. So to convert between radians and degrees, okay, if you are given something in degrees and you want to change it to radians, you simply multiply by pi over 180. To change it from radians to degrees, you're going to multiply it by 180 over pi. Okay, let's look at a few examples. Our first example, What is the degree measure of an angle of -3/4 pi radians? So we want to change it to degrees. So all we do is multiply it by 180 degrees over pi. Radians cancel. 4 goes in here once, 4 goes in here 45 times. 45 times -3 is -135. Next example, the other way. What is the radian measure of an angle of 27 degrees? So 27 degrees times pi radians over 180. Divide both of these by 9. Multiply, and we get 3 pi over 20 radians. Okay, that should be relatively easy. Let's look, and this is when I made the note about being a good time to memorize your unit circle, because if you have your unit circle memorized, you don't have to do all the 45, 45, 90s and 30, 60, 90s. You can do these with the geometry using 45, 45, 90 and 30, 60, 90. So you need to make sure that you remember those. If you don't remember those, just ask me on Remind and I can send you the rules. Okay, we're going to find cosine and sine of a radian measure. So let's review. XY, ordered pairs, is equal to cosine sine. Okay, alphabetical order. It's going to give you the same thing. So let's say you have a circle, and we're going to look at pi over 4. So here is our pi over 4 mark. And we know it's a unit circle, so everything is moving over 1 unit. So if I draw a right triangle, and I know that this is 1, and I know that that is opposite the hypotenuse, so that's my 90, correct? And then the 90 is equal to what? Side times square root of 2. So if I say 1 is equal to s square root of 2, divide both by square root of 2, then I can't leave the square root of 2 in the denominator, so I have to multiply top and bottom by square root of 2 over square root of 2. That's going to give me square root of 2 over 2 on this side and square root of 2 over 2 on this side. So if I think about this, the ordered pair here will be over on x, square root of 2 over 2, up on y, square root of 2 over 2. So if I want the exact value of the cosine of pi over 4 and the sine of pi over 4, square root of 2 over 2, comma square root of 2 over 2. So they are both square root of 2 over 2. Now, you can rewatch whatever, you can slow it down, you can look at the problems, but if you have questions, make sure you're asking me. Okay, last thing we want to talk about, the length of an intercepted arc. So for a circle of radius r and a central angle of measure theta, so there's my theta, and then I've got radius r, radius r. The length s of an intercepted arc is s equals r theta. That's your formula. So these should be pretty easy. Finding the length of an arc. So this is what I know. I know my central angle here is 5 pi over 6. Central angle here is 2 pi over 3. I know that the green is B. I know that the pink is S. And I want to know what is the length S to the nearest tenth. So S equals radius times theta. Radius is 3. Theta is 5 pi over 6. So when I multiply these together, I get 5 pi over 2. And on my calculator, if I divide 5 times pi by 2, I get 7.9 inches. And it said round to the nearest tenth. So there we go. All right, you have your homework assignment for the next 2 days, which will concern what we discussed. Rewatch it if I'm going too fast. Remind me questions if you're not sure about something, and I will see you soon. Bye.